Okay, Assalamu alaikum. Good afternoon, everyone. Thank you for your presence today. I'm going to talk to you about the application lifecycle management, the next generation, including a lot of components that we are going to discover today. So the first thing, I'm Jamal Reda, Senior Technical Architect at Salesforce, and I've been working for more than 10 years with Salesforce, include on core platform. And in the last 2-3 years, I've been doing more work on the CI/CD automation with large scale customers. So let's start with the first picture, actually. So when you see this mosque, the first thing you ask yourself, who designed it, who built it, what are the specificities about the sculptures, and how tall it is. But the most impressive part, it's not even visible. It's basically the foundation. And the foundation is the most important thing. If you don't have the automation, you don't have the foundation, you cannot build on top of it. So why is this a big deal? Why the ILM is a big deal? So basically, the platform, it has grown, and it's still growing. And with the Customer 360 platform, we keep innovating and adding a lot of features. And basically, without a foundation, you cannot scale. You cannot do an innovation. That's why we urge our customers, basically, to move to the next generation of ILM using Salesforce DX and building their own custom plugins. Because basically, with Salesforce DX, you can move toward to the solutions directly, instead of going around multiple things and building a lot of complexities and scripts that are not basically scalable. So before we jump into the solutioning and jump into technicalities, I'm going to take an example of a customer, one of my customers basically, who started basically before 2015. They started small, and in the first projects they started with ChangeSet. So many of you, I believe, ChangeSet, they know it. It's a standard feature on the platform. It allows you to do a lot of good things, but it has a lot of drawbacks. And basically, one of the drawbacks is the fact that developers, they do build on the same platform. And when you have two developers building on the same components and sharing the same metadata, you don't have versioning. So basically, when you try to release one functionality from an environment to another, you're not taking a fully implemented features, but you take the latest version. And this is the first problem. You don't have versioning. The second one is the fact that with ChangeSet, you don't have actually an end-to-end deployment process, but you just deploy from one environment to the next environment. And when you need to promote it to production, you need to create another outbound ChangeSet from the second environment till it goes to production. And that was the second problem. The third problem is the fact that it does not support all the metadata. So that's why you need to stay away from ChangeSet. And that's basically what the customer did. After a couple of projects, they realized that ChangeSet is not the best solution because they cannot scale. That's why they went with the Ant Migration tool, which is basically a jar where you have the build.xml and build properties where you can build a lot of automation. And they have used the proper CI/CD process with Jenkins. They were able to scale at that time. They onboarded multiple projects, but at a certain time, they went from a mono-org to a multi-org, and from a couple of projects to more than 60-70 projects that they are working right now. So at that time, they realized that they cannot scale more. And basically, they started to have bottlenecks on the deployment. So instead of focusing on the quality of the deployments, they were focusing on the deployability. And the failure rate, it was around 70% of failure rate. Now, that's why we had a discussion with the customer, and we decided to move to the next generation, which is to move from a metadata format to Salesforce DX, where you have a source format. So what does a source format mean? It's currently, for those who know Salesforce and knows the metadata format, if I give the example of an object, if you have worked with the legacy format, in an XML file, you do have the definition of the object, plus you do have all the fields that are related to the object. But when you move to the Salesforce DX, it is more granular. So basically, it will give you the power to reduce it to multiple components, so that once you have multiple developers working on the same repository, working on the same shared object, whenever you create a new thing, basically you don't interfere with others, and it will reduce the conflicts. That's why we stand now with a solution with Salesforce DX plugins, actually, which is the topic that I'll cover in the next slides. And with Salesforce DX, we have onboarded right now 4 production orgs and more than 70 projects, which means that it drastically reduced the deployment failures from 70% to less than 5%. And this is just because of the power of Salesforce DX. Now, enough talking about this, but where do I start if I want to build an application lifecycle management? Basically, when you talk about ILM, you are talking about the governance topic. And when you have a governance, you need to start planning. Basically, you need to have a vision and you need to have a strategy. Because without a vision and strategy, it's like you go into a black hole. Now, what about the technology? So for those who doesn't know what a CI/CD is, I believe most of you does, but I'll explain it for the sake of a presentation. CI/CD, basically, it's a set of practices that will help you promote your changes from one environment to the next environment until it gets deployed to production. CI stands for continuous integration, which is the fact that you are going to integrate your metadata into your repository and by respecting a set of validations. And the CD, it's the continuous delivery or deployment of your metadata that were previously merged into the repository to the next environments, including a set of processes or validations for instance, the test class execution, the validations in the org, the code quality check, and so on. So now, I'll be presenting the landscape of an application lifecycle management. In general, ILM, basically ILM stands for Application Lifecycle Management, which is the process of the continuous integration of your application or the life cycle of your application from the design of a requirement until it gets deployed to production, the support model, and until it gets decommissioned. Now here in this landscape, you see a lot of common ingredients or a lot of common components in terms of a repository where you have to work with the source format repository that respects the SFDX format, which gives the granularity. And in terms of, once you have the repository, basically you need to define what is your CI/CD server. In our use case, we are using Jenkins. And in Jenkins, it is hosted in Kubernetes. The reason why we went for Kubernetes also is to go into a serverless architecture and at the same time to provide the auto-scaling functionality. Now imagine that you have a process where you have Jenkins that is hosted in one server and you have a set of executors that are predefined in this instance. Whenever developers, they create pipelines and they execute basically pipelines, it consumes from the same CPU and the same memory. And this basically at a certain time, it will lead to lack of resources and the waiting time will keep increasing. So that's why we went to Kubernetes. And at the same time, the integration between the repository and the pipeline, it is done through the webhook integration. Now within the pipeline, we are running with a Docker image. So this Docker image in the background, it will run a couple of executions so that it will integrate with the Sonar. We are using SonarQube for code scan analysis, static code scan analysis. And the code scan analysis, how is it run? It's not running from the Jenkins server, but it is being called from our our introduction, basically, which is the SFDX plugin. So for those who doesn't know what the custom DX plugin, it is like a powerful functionality that lets you build a tailored application of your own with your own processes, and in the background it can integrate with all the different systems through APIs. REST API, SOAP API, REST API, Tooling API, Metadata API, and so on, and also integrate with the other systems. Now, the secret sauce in this landscape is the fact that there is a centralized app. Centralized app, it's an application that was built on top of Salesforce. It has a specific data model, and instead of having an application lifecycle management where everything is technical, you are having now a solution where you can track your release, your application, which makes it more data-centric and gives you an early feedback about your information, and all the ILM artifacts, like the components, the environments where I'm running, the build, everything is stored in the centralized app so that you can report on it and have an early feedback. We'll go through more details on each of these components. Now, before you start your governance process, you need first to define your environment strategy. And before you decide which environment, you need to ask yourself a couple of questions. First thing is, how many sandboxes do I need? What are the type of sandboxes that I need? And basically, what is the refresh period that I should apply to my sandboxes during the life cycle of my application? Once you have Okay, so this is an example of an implementation of an environment strategy where you have your projects. This is the context of a multi-org context and multiple applications. So you do have a local environment where you need to provision all these environments at the beginning. And these environments, they are provisioned also through Salesforce DX plugins, where you have pipelines that will be running in the background, where Jenkins will play just the role of an orchestrator. And in the background, it will call the necessary APIs, tooling API, so to create, refresh based on a periodical time frame. So once projects, they have built their releases in the local QA, well, which is their own UAT, they need to go to the higher branches, which means to the higher environments that are shared by different projects. And this is where basically you have to introduce a validation in environments, which will remove the bottleneck that many of the projects are facing when deploying to the managed orgs. If you have multiple projects integrating and deploying to the same environment, you will have a lot of conflicts that you have to resolve. And at the same time, if you are running all the test classes on these environments, the waiting time will keep increasing, because as you know, in Salesforce, you can do only one deployment at a time. And if you don't have releases that are ready, it will increase the time and it will lead to problems. So that was the approach here for this example. Now, after you define the environment strategy, the next thing is to define also the branching. And before you do that, you need to ask also yourself a couple of questions. Do I have a multi-org? Do I have a multi-app? And at the same time, how can I resolve conflicts efficiently? And at this, also, if I need to release multiple applications at the same time in the same managed environments. Managed environments are the environments where all the projects, they meet together. So with this, we went to an approach where you have a branch per environment, which gives you this environment. This is the source of truth. The source of truth becomes the repository, which is the branch itself that represents the environment. And then basically, once you have your release prepared and all your features have been merged into the release, you want to go to the higher branch. We went with an approach of reverse merge from production down to the shared QA. As you can see, we have production, we have pre-prod, and we have UAT. So we created a branch from the top to the bottom, and basically this will reduce the conflict resolution. Basically, something that is in production is already in pre-prod, and it's also in UAT. So if you do a back merge you create a branch from your release, and then you do a back merge from production down to the UAT, you don't have to resolve the same conflicts twice. Plus, we introduced a resolve branch process. This is something more technical. I can go into details maybe after the session. So also, imagine that you have, in every CI/CD process, early feedback is important. Why? Because basically when you provide an early feedback to developers, you will improve the quality of your code, the scalability of your solution, and also you will, the developers, they will be efficient. It doesn't make sense to provide the feedback only once you try to deploy to UAT or to pre-prod. The sooner you give it to the developer, the better it is, and also you won't face the problems during the next deployments. That's why we went with Sonar for code quality check, and we went with an architecture of a new code scan. So what does a new code scan mean in Sonar? Basically, you create your repository, you do a full scan, and whatever comes after, for the reference branch, which is the master branch, basically, whatever you scan after it, it will be considered as a delta scan, which is the new code. It never scans the whole repository again. It will be time consuming, performance consuming, so it will scan only the delta. Besides, to improve the experience again, you will have to use the pull request scan, which means for a developer experience, whenever he performs a commit, he has a pull request that is created. And basically the pipeline triggers. The pipeline never takes all the branches or the whole code in the branch, but takes only the delta that I have in the pull request, pass it as a parameter, and then based on the new code's reference, it will scan only this, which means that it will reduce drastically the time of execution. It goes from 15 minutes to 2 minutes probably. For features, for releases maybe a bit more, but in general that's the experience. Okay, now imagine that you have a CI/CD process with a Jenkins server in our example. And basically you are suffering from a disruption of service whenever you whenever you need to upgrade the plugin in the instance, in the Jenkins instance. For instance, you have a Sonar version of the software. Tomorrow you need to upgrade. You will need to ask all the projects that are onboarded on the platform, that are running on the platform, they need to stop. There is a downtime. At the same time, imagine that you have multiple projects and multiple pipelines, a pipeline per project. Also, imagine that you have one repository where you have all your Salesforce metadata. And at the same time, you have a folder where you have all your scripts regarding the deployments. Every time you need to upgrade, you need to ask all the projects to stop. And I need to upgrade my new version of the plugin. This experience is not optimal. So that's why we went with an approach of one repository per production org. And inside this repository, there will be Salesforce metadata that belongs to all the projects in the org. And at the same time, there will be one default Jenkins file. This default Jenkins file, it's not used for deployment, but it will act as a loader. What does this mean? Basically, if you have a pull request, developer performs a commit, and you create a pull request. Initially, it will execute the loader, which is the default Jenkins file, which is the same for all the projects. Through a mechanism, we are loading the real ILM Jenkins file, which is hosted on a different repository that is maintained by the ILM team, the Application Lifecycle Management team, where we are building plugins, where we are maintaining the Jenkins file. We do have a different lifecycle. And through this mechanism, we are loading the Jenkins file, where all the magic happens, where we do have a declarative pipeline, where we do have a Docker image, and where we have all the different stages that are calling. This Docker image, it has the custom plugins already linked to the pipeline. And it will run the different stages to perform the actions, and then return the response to the developer through the flow. Now, within the same process, talking about the pipeline that is being executed, imagine on the same fact that you are installing basically the Sonar scanner, you are installing the Salesforce DX inside the Jenkins, you are installing the CLI, Java JDK, all the necessary tools for you to deploy. When you do that, basically there is dependency of this version of softwares for all the developers. And also the resources that are being shared between different developers. They are not running within a specific container. They are not unique to the developer who is executing. That's why we recommended to go with a Docker image. A Docker image, it's like a place where you have all your softwares being installed, and it is unique to the developer who is executing, because it will tag it will create an image for that developer. And not only this image it's running inside a pod. A pod, it's like a container that is created within Kubernetes, inside an elastic Kubernetes instance. And basically also provides the flexibility of having dynamic pods instead of having executors. Okay, now what is Salesforce DX? It is a Salesforce product that is available on the App Cloud, and it is used mainly by developers to build and manage their applications in an efficient way and direct. So basically, previously, if you need to execute tooling API, you need to go through Postman, basically, and you need to perform an API call. With Salesforce DX, it comes with a set of pre-built plugins that you can execute, and they will leverage different APIs of Salesforce. Tooling API for creating sandboxes, refreshing sandboxes, metadata API for doing the retrieval, the deployment, test class execution. And all of them, they can package with the Salesforce CLI as a separate packages, but they are pre-installed, bundled with the CLI. Now, what the plugin generator also is an important block in our solution. Basically, it provides customers to build their own applications. So the plugin generator, it's like also you execute a command, plugin generate, and in the background it will generate all the necessary libraries, all the necessary folders, and at the same time you can extend from the Salesforce platform. So the CLI and the DX, they come with libraries, default libraries that can integrate with Salesforce. And the plugin generator generates that one so that you can build your custom plugin where you will extend the platform. It's not only about Salesforce APIs, but also all other systems. In our use case, we are integrating with Sonar, we are integrating with Bitbucket in order to create a pull request, to create a commit, to create a stash components, and at the same time also for Sonar to trigger a scan and also retrieve the results of the scan. I'll give an example of an end-to-end solution for the custom plugin. Now, this is specific, yeah. So imagine that you have an ILM solution. So this is not a common component in the ILM solution, but this is something that we have built for a customer for over 2 years, and it helped us to turn from a solution where it is technical. Imagine that you don't have visibility about the deployability of your release. You don't have informations about how many releases you have deployed, how many releases they have failed, how many features I have added, when I am running, where I am running. So that's why we have now, in the other way, imagine that you have all these informations. And this is the custom application, basically. It's a data model in Salesforce that we have created with different personas, different roles. And now, everything that you didn't have before, you have it now. So it gives you like a maturity in the process where basically developers, release managers, and also stakeholders, they can report and they can have visibility on how many releases they were released to shared QA, to UAT, how many releases they are in QA, how many they have failed, how many features. And also you can go to the low-level detail of a component. I have added an Apex class, I have added a custom group, what is the version of this class, where it was added, and so on. And at the same time, when you run a build in Jenkins, you don't need to go to Jenkins to check the log, or you need to go to Bitbucket to check the quality of the code. You basically go to this centralized app where you have a build record and you can track, you have all the informations about the build, how much time it took, the test classes that were executed, and so on. So this is like we call it the enabler, because it is the heart of the solution and everything around it is integrated. Okay, so this is an example of flow. Let me take me as a developer. I have my Visual Studio. I have Salesforce DX installed, and I have my plugin, custom plugin repository. I'm going to check out my repository, and I will use plugin link to my custom plugin to the Salesforce DX, which will become also as an add-on. Now, when the developer from his machine, what he needs to do, instead of going to Bitbucket, creating the branch by himself, and then checking out in the repository, he just needs to execute sfdx feature commit and providing multiple flags. And the name of the feature, the name of the release from where I'm creating the feature, the environment where I am running, and also, do I need to run test classes? If yes, what are the test classes that you want to provide? Do I need to run a build, or I just want to run Sonar in the pipeline? All these informations are provided by the developer. In the background, when the plugin runs, it will check all the necessary permissions. For instance, in the centralized app, does this developer have access to this feature? Does have access to the application? Do I have permissions to create the branch? And in the background, it will create all the branches from Bitbucket, perform the commit stage and perform the commit and push to Bitbucket, and also in the background create the necessary data in the centralized app. After this is done, once the PR is created, basically there is the integration between Bitbucket and Jenkins through webhook. So the multi-branch pipeline, it will initiate the first stages. The first one, throw a YAML file to execute inside Kubernetes. Then it will run within an ILM image that has our custom plugins, basically, and start the first stages. So since this is a process that is data-oriented, you will not find a Jenkins file where you have hard-coded, basically, stages, where you say, if it is UAT, do this. If you have pre-prod, do that. You have one stage for deployment. And basically, based on the data that is stored in the centralized app, I know this release is in which stage it is, what I need to perform now. Is it a validation? Is it a deployment? And then it will retrieve all the data. What does this mean? It is a custom plugin that will call the Salesforce API to do a retrieve SOQL query, basically, to retrieve the data, format it in a JSON format, and then take action, which is a declarative stage in Jenkins. For those who knows Jenkins, it's declarative stages. And that's why it will run the stages, for instance, running the validation in a CI sandbox, running with the X test classes. And once the feedback is returned, it will update the centralized app as an artifact. This is the link of my pipeline. This is the link of the PR. The status of the release, was it a successful validation or no? And also a couple of other informations for reporting. This is how it looks like. Sorry if it's not that much visible, but you have the developer executes the plugin. Initially, it will check, for instance, if I have the necessary validations. If not, it will exit. The developer, he will basically ask for permissions. So if I need to approve a feature, the technical lead will go to this application, centralized app, go to the feature, review the code. Basically, he has the link to the PR. He will go review the code and then come to the application and approve it. For instance, there, as you can see in the step 2, approve it forever. Only then he will be able to execute the command. And after that, in the background, we are managing all the necessary deployment steps. So we are managing not only deployment, but we do have the post-destructive, pre-destructive changes using the DX, of course, format. And in the centralized app here, you do have, the possibility to link a feature to multiple features to the same release. You do have the list of components. Doesn't look like it's visible, but I'm sorry for that. You do have then also the release environment. So I'll go into this more detail. So in the pipeline, we have used the Blue Ocean for a better user experience. Basically, you will run multiple stages, and in Bitbucket, you never go and merge or decline. You just consolidate, see the data, and then go to the centralized app. And after that, it's up to Jenkins to decide if I need to merge or I need to decline. Yeah, so this is more or less the same detail. Okay, so whenever you need to build an application lifecycle management, you need to have a vision and a strategy. You need to define your lifecycle. You need to build the team with the right technology. Basically here you need to have knowledge about TypeScript. You need to have knowledge about branching strategy. You need to have knowledge about Salesforce DX and Salesforce APIs. And don't build everything from the first sprint. Start small with an MVP and then iterate. So with that being said, I think I completed my presentation. Thank you. And if you have questions, do not hesitate. Yeah?
You mentioned that it's better, like best practice is to have multiple orgs, like production, pre-prod, and the other one. But isn't it going to take more time to deploy, or?
No, you will have to define the environment strategy, where it depends on the scope of the customer. But in general, for small customers, you need to have a UAT environment, you need to have a pre-prod, and then production. And in the bottom, you will have a developer sandboxes and a QA environment. The life cycle of this application doesn't take time. It improves as long as you have a governance process around it. It doesn't matter how many sandboxes you have, but the process is what matters the most. Sure. Yes?
I want to understand the purpose of using Kubernetes in the process.
Okay.
Is it like to manage multiple orgs?
No. We have used we are using Kubernetes basically to auto scale. So imagine that you have one production org, just an example, one pipeline, and you have 5 projects. And in each of the projects, you have 2 developers. These developers, they will run commits. Whenever they run commits, they will execute a pipeline. An instance of the same pipeline will execute. So when you have just an instance of Jenkins, you do have a specific CPU and specific memory, and you do have a set of executors, static executors that are on Jenkins. Once you consume them, it's then if you have 10 developers running and you have 10 executors, the first 10 who arrives, they will take these executors. The 11th will stay in queue, because he does not have enough resources. When you go with Kubernetes and you go serverless architecture, basically pods, they are created dynamically. And once you reach, for instance, as per the policy that we have set up, once you reach 75% of capacity, we will do the auto scaling, which means you will create a new node, which is a new instance. And inside the node, you will create a new pod that will be dynamically provisioned inside the pipeline. Sure. Yeah?
Is there any benefit in using Jenkins over GitHub Actions or Bitbucket Actions?
Well, basically here, Jenkins is more powerful, and That's it. You can run also from GitHub. You can call the DX plugin. Yeah, because basically you can run also with a container, with a Docker image. And this Docker image can do a lot. In our solution, basically, we don't do only the deployment, but also the automation of the repository. So in case you have an onboarding process and you have a rollout, you have multiple projects that are running on legacy deployments, because customers that are industrial, they do have an existing process. So when you come and you want to change the process to new, you still have legacy. So you need to maintain also the deployment that are still running from the legacy. So you need to synchronize the code. You can't do this only with classic deployments. You will need to run background pipelines. Jenkins plays the role of an orchestrator. So you schedule pipelines that will call the DX plugins, which will retrieve the metadata from the org and synchronize them with the repository. So it is more powerful in this context. And with the Git, you can't actually use Kubernetes. So yeah, it's just for one project.
Do you use any packages in your deployments, or do you do everything through the...
It's not unlocked. We are not using the unlocked packages, but this is I would call it a classic deployment process. The only difference is that it's a source format instead of metadata format.
One more very specific question.
Yeah, sure.
We also have the CI/CD pipeline going.
Okay.
What we experience is that once we have a lot of test classes running,
Yeah.
we experience record logging.
Yeah.
I've Googled, and I think a lot of people
Yeah.
are having this issue. Have you also seen this issue, and if so, have you solved it, and if you've solved it, how? Or
So basically, in which use case you are talking about? So if we are talking about all test class execution, we recommend to go with the parallel test class execution. And parallel test class, yeah.
But if you keep it parallel, then we test all our flows. So all our flows we build, and we do quite a lot of flows. Test classes for to make sure that...
So what we are doing, yeah, when we experience the lock row, well, basically, we are taking all the test classes, we run them in parallel. And it's not only about the lock, but also the timeout. Sometimes you do have test classes that do have multiple methods, and it does timeout. We are taking all these test classes and running them serially, separately. And you keep iterating, because that's a plugin also that does all this logic, keeps iterating through the failed test classes until you get the full response. But straightforward solution, I don't think there is. Yeah.
I have a question, because from what you are saying now, like with sandbox generation, with this retrying of testing and so on, it sounds like a lot of custom SF plugin solution. So my question is, are you mostly orchestrating existing open source plugins, or is it like mostly your custom code that is closed source? And
Well, this is a solution that we have built. It's been, a full solution starting 2020. It's with one of the big customers, with Unilever. So that's become a product now. Yeah. Not yet open source on the GitHub, but that's my plan, basically, to move it to GitHub. Sure thing. Because basically, sorry, Amar, but basically the secret here is also not the automation that is around, but the data-driven architecture. This is not something that I have seen in projects. You have only technical information. If you need to report on something, you don't have this information. You cannot get it. But if you provide it, everyone will adopt it. So that's like a secret sauce, if you can say.
My question is regarding the centralized app.
Yes. Yeah, okay. Good question. Basically, the customer, he has 4 orgs, an enterprise org and 3 regional orgs. The application is hosted on the centralized, on the enterprise org. And we are offering also a community to developers. So you don't need to provision an internal license to developers, but it's only a community. And also with Salesforce DX, community users, they can authenticate. There is an authorization web server flow that they can authenticate and leverage the APIs of Salesforce. So yeah, it is hosted on Salesforce platform, and there is a community for developers and release managers to access the application. Yeah, it is a fully branded solution. It's like an app. You have an app object, you have a release object, a release component object, a release component environment object. All this data model has been designed for the sake of the solution. No, it is my package. Good question. Basically, we created also a plugin that leverages the Salesforce Bulk API. and it will perform the. Right now, it supports only the delete of data based on a retention period. So, for instance, you do have a cascade data model. You want to delete this one and this one and that one, and data that is beyond 6 months. We provide also a data model where you configure which data you want to delete, from where you want to delete. And there is a background pipeline, the orchestrator, Jenkins, that runs every 2 minutes and checks if I have a configurator already there, for which environment I want to run this, for which project I need to do that. And it will run and do the delete, the bulk API. The seed data is something else. So whenever you spin a new sandbox, there is a seed data. Basically, I need to have a list of accounts, a list of contacts, a list of that. This is something you can use with the normal Salesforce DX plugins. You just have it there, and you have it there, and the script will run the insert. Yeah.
Can you describe a little bit the ALM team?
Okay. So in the team that we have built, we had a mix of developers who knew what Salesforce is. They had a bit of knowledge about Salesforce APIs, Salesforce Lightning Web Components, and they had knowledge about TypeScript and DevOps. We had other team members, they didn't know what Salesforce is, but they had extensive knowledge on TypeScript. The key here is TypeScript, and also some knowledge on CI/CD processes and API management. Because when you interact with Salesforce, you interact mostly with APIs. So if you have the pattern of APIs, you will be able to upscale quickly. And build inside the platform, who knows TypeScript can build a Lightning Web Component easily.
I have a question about Sonar.
Yes.
Is it is it triggered by Jenkins or from the version control?
No, it's not from version control. So basically, once the PR is created, it will trigger the pipeline. The pipeline, it will execute inside an image, a Docker image. The Docker image, it already has the Sonar client already installed, right? Now, the first stage, one of the stages inside the Jenkins file, it will call a custom plugin, Salesforce DX custom plugin. This DX plugin, it will build the Sonar string, we call it a Sonar string, where you pass what are the source files that you want to scan, which projects you need to scan, what is the endpoint, and so on. And you start the spinner of Sonar Scan from the plugin itself. So the pipeline, Jenkins, does not know about Sonar. It just calls it from within the image, and the image calls the plugin, and the plugin performs the API. It goes to Sonar, passes all the necessary sources, and then performs another API call to get the background task. Background task, it means the background operation that is happening in Sonar. Did the scan finished, have the scan finished or no, and what is the output, how many issues I have, and so on.
So in case the Sonar scan has failed, the pipeline keeps going or it's
It depends on the process that you want to set up for your customer. In our use case, if Sonar dies technically, it will continue the process. It will just highlight that there is a warning. It's going to be an unstable pipeline. But if its Sonar works and it scans and it returns, basically you have 50 issues, then basically what we are, as per the process, we are failing the pipeline, because we want this information to be highlighted to the developer so that he cannot go further. But you can tweak it, or you can change it to say, if you have just added a command on the issue, I want to consider it as a pass. So it depends on the process of the customer. Sure. Come on, more questions. I can take the full day. One more? One more?
I have a question, because you say you use SonarTube, which you mentioned is problematic with Apex from time to time. Why, for example, not PMD?
It's just basically the first thing, the customer already had Sonar. That's one thing. And Sonar will basically, with plugins, we are using CodeScan. Code Scan as a plugin, it comes with a set of rules that are predefined to provide you a better experience. There is one more topic that I haven't talked about, but it's like an engine that scans profiles, custom labels, and also it's like a set of rules. We have built an engine that does scan all these files. If you want to do it in Sonar, it will consume the line of codes, and you need to pay more. So it's like an engine now where you, for instance, if you have created an object, and you haven't provided the prefix, we are going to capture this as a violation, and in the centralized app, it will actually attach it as a violation to the release component, telling you for this environment, for this validation, you have a component without a prefix. So then you need to ask for an exception. In Sonar, you can do the same, but it will consume the line of code. PMD, we haven't tried it, but it will work the same way. Okay? C'est bon? Okay. Thank you all for your presence. It was a pleasure. Thank you.